So, okay, welcome everybody. So I'm going to kick it off with a few basic questions here, just to kind of set the stage. A lot of us here in the research community have been in this field for quite some time, and I just want to get an overview, kind of this arc of progression of this field. And I want to just start off maybe, from left to right, or start with Vadim, or if anybody else wants to jump in. But what's the general sense of the current state of longevity or basic aging research here now in 2018? Compared to when you first started in this field, and how has it changed? You could kind of riff on theory and practice, but how do you see it now versus how it was when you entered the field?
So I think we are at a very exciting time because there are so many opportunities now in the aging field. We have first approaches to rejuvenation. We have biomarkers. We better understand the aging process than before. So it's a very exciting time, and I think we are ahead of a major transition in the field, in a sense, because we accumulated so many tools. But at the same time, I would say that we are at the very beginning of the road, not in the middle or not at the end, because as we discussed today, there is no clear understanding of what we are targeting. What is the aging process and what should be the targets? So I think it's still a long wait before the actual rejuvenation therapies will be available. Probably we would be able to extend lifespan, a little bit of human lifespan, 20%, 30%, because we know that it can be done in all model organisms. There is no reason why it shouldn't be done in humans. But more sophisticated approaches, I think, would take more time.
So 25 years ago, aging was viewed not very kindly by most of science, and I think that's changed radically in the last 25 years to today, where I think it's a very desirable field of study. I remember working with Dr. Timmerus at Berkeley about 20 years ago, actually. She tried to actually, she didn't really go out quite actively in saying that she was an aging researcher, or that's what she was, but she kind of couched the research in kind of different ways so people wouldn't kind of criticize her. But I think now we're perfectly comfortable telling people what we do, and I think it's very well accepted. I think if you remember seeing my slide that when a company like Google starts to look in the field, I think it's time to get really serious here, and they're getting very serious about it, and a lot of companies in the Silicon Valley. And when I mean Silicon Valley, by the way, I mean the entire Bay Area. So Silicon Valley, by the way, isn't Silicon Valley anymore because most of the silicon's being done in Singapore and China and Japan. So it's really software and computer and I mean, it's Technology Valley. How about that? Because all the technology I mentioned are being worked on in that area. And I'm originally from Canada, by the way, and I naturally migrated there because that's where the future is being invented. And I believe, Aubrey, it's no accident you're in Silicon Valley and not other places in America, I believe. So both of us are actually not Americans. We're not born in America, but we gravitated to Silicon Valley because of the reason that that's where the future is going to be invented. And so, so aging, I believe, is going to be propelled forward enormously by people like Aubrey and all of you here, if you are interested in the field and helping us move forward. But Silicon Valley is definitely hell-bent on figuring this problem out because that's what the Valley does. It solves problems.
I certainly agree with what the others have said. I would say that there is actually another even bigger thing that's happened, well, arguably bigger. Certainly, when I started in this field 25 years or so ago, a large part of why I switched from working in artificial intelligence research was because I discovered that gerontology was a real backwater. It was considered very poorly by most other biologists, and hardly anybody was working on it, and it seemed like the people who were working on it were mostly not working on doing anything about it. The thing, when I started to come to conferences and get to know people, I found very much what Steve just said, that even within the field, thinking about actually intervening in aging and postponing it was largely, not something you did. You never kind of mentioned that in a grant application or anything like that. And it's fun to go back over the years and look at the subtitles of the major conferences. So, like, there's a conference every year run by an organization called the Gerontological Society of America. And each conference is called something like, the 28th conference of the annual meeting of the GSA, but then there's a subtitle. And the subtitles have changed over the years. Back then, the subtitles would always be about understanding aging better, and now, every single year, it's all about doing something about aging. It's all about intervention. It's all about actually keeping people healthier for longer. And, of course, Vadim is completely correct that we can't do it yet, to speak of, and it'll be a little while before we can. Vadim and I probably are a little bit different from each other in terms of our predicted timeframes, but we all know that the timeframes are very speculative. We just don't know how long it's going to be. We just know that the harder we work, the sooner it's going to be. And the fact that it's now respectable to talk about intervention is the first and biggest hurdle, and it has been overcome now. It's possible to talk to other biologists and other scientists, and indeed the general public, about the possibility of bringing aging under medical control in a way that was unthinkable even 10 years ago, and certainly 20 or 25 years ago.
So yeah, I totally empathize with the whole backwater aspect. I just entered the field 18 years ago, and I remember when I was just looking for laboratories to work in before I joined David Sinclair's lab, when he himself just joined Harvard Medical, and I was one of his first grad students. It seemed like a dirty word. I was looking for, labs that were working on, telomeres or cancer or not aging, right? Certainly not longevity, because that's kind of way out there. But it's changed dramatically. And what would you say specifically has happened, some specific milestones over the past 18 years or so, that now we're here talking about interventions, and now it's not so much of a backwater. We're just not making laundry lists of things that go wrong, but we're talking about interventions. What are some of the key developments, very specifically over the course of, a decade and a half or 2 decades, that has gotten us to this point here, like a little bit more precisely for the audience?
I think that the main development is the overall development of science in the genomic revolution, for example. So, much of what we know is defined by genomics and, in general, omics approaches. Because aging is a systemic process, the only way to study it is to study systemically. And we have to use advanced computational technology and advanced omics approaches. And this is something that now is being used, but which was not before. In terms of the concrete developments, it's hard to say. I would say now we know that lifespan of all organisms that we try in the lab can be altered. Yeah, I think this is an important development. So this should apply to humans as well. There is no reason it cannot apply. Other developments, I don't know, in vivo rejuvenation approaches. I think this is something like Yamanaka that developed IPS. It directly applies to the aging field. Still there's a long road ahead of us.
So I think many things have happened in the intervening 25 years or so. I'm a bit of a technology person, so I'm going to have to kind of rely on that. And that, well, for one, how about the Human Genome Project? Okay, so 25 years ago, it was 1993, and the Human Genome Project was just starting, and very, very, very slowly. And when Craig Venter came on the scene, clearly things went up at an exponential rate. But they were predicting that it would take a very long time. There were predictions of 20, 30 years, and the cost estimates were just way off the charts. But when when modern sequencing technology came online, thanks to, by the way, computer technology, because the two were very tied together, the Human Genome Project, actually I think about 80% of it was done with 10% of the time, the whole project. So again, it was an exponential increase. So I think technology, again, I hate harping on that thing, but I think it's critical. 25 years ago, by the way, who heard of the internet in 1993? I have no idea how it could conduct my life nor my research without the internet. Now, I know that it's like, what does the internet have to do with aging? Well, it has quite a lot to do with aging, because I don't know how to book my airline ticket to come here from California, or a million other things we use the internet for. How would I search PubMed? How would, for example, artificial intelligent robots read all this information that's on the internet and so on and so on and so on. So I think, and also I'll have to do a shout out to Aubrey here, because in addition to technology, I think awareness has been huge, and Aubrey's done a great job in letting people know that this is a problem that is fixable, and so I think those have been, and obviously right now we don't need to couch or hide the fact that we're doing this work, because it's very well accepted now, and I think so I think those two factors, really the technology and the publicity that this is a fixable problem, I think those two things have been major factors in bringing us here today.
Yeah, thanks, Steve. Guess I've made a bit of a contribution when it comes to the advocacy side, and largely I think, perhaps just being out there and saying things that were initially regarded as completely crazy and wrong, and just getting away with it. Actually being able to say the same things for a decade or more and not be demonstrably knocked down and shown to be wrong, that's actually quite powerful in terms of changing the whole tone of the conversation that's gone on. So I think perhaps just by putting my head above the parapet so much, that helped. But in terms of the technological developments, I think, yeah, absolutely. The generic developments that have happened, whether it's the Human Genome Project or the development of CRISPR or the development of IPS, all of these things, which of course have huge relevance across the whole of medical research, have also got a huge relevance in terms of the credibility that attaches to the idea of bringing aging under medical control. I'm actually rather more pessimistic than most gerontologists with regard to the idea that we can extrapolate from laboratory organisms to humans in terms of longevity. I believe that not enough attention is paid to the fact that longer-lived organisms seem to be much more difficult to life extend than short-lived ones, especially by simple methods that relate to calorie restriction. This should not be ignored because, first of all, it's very obviously true, and second of all, it's not even a surprise. It's pretty obvious just because long famines are less frequent than short famines in nature, that you would expect that short-lived organisms would have machinery to respond to famines better than long-lived organisms will. But saying that, I don't object to the fact that this has been somewhat swept under the carpet because it has contributed to the increased credibility of the idea of doing something about aging, even if by what I would say are scientifically fragile arguments. So yes, I mean, all of these things matter, and I think it's really the sum total of all of these technological and rhetorical developments that has led us to this much happier state that we're in now.
Right. Now, is there a technology now that you see that's maybe nascent or being developed right now, or maybe it's just about to become mature, that you believe is going to really push this field forward dramatically? Is there something that excites you right now in the field of, I guess maybe specifically aging and longevity research, but it could be outside of longevity and aging research, something more generic like AI, for example? Is there something that, if somebody said, what is going to give us our biggest bang for the buck that's going to really push this forward? Is there something on your mind, or is it still a bit hazy?
It's hard to say. I would say AI and biomarkers of aging, because these are the tools that can be used to accelerate aging research. So it does not need to be just epigenetic biomarkers. Could be more sophisticated biomarkers that will be developed in the future, but we know already that there are some biomarkers. I think there's the first generation of biomarkers that are available, and I think it's very exciting.
Yeah, I'll have to agree with that and probably add a little bit more to that. So clearly AI is going to make a huge impact on this field, and actually we attended a conference at the Buck Institute, which is in Nevada, which is just north of the Bay Area, and it's a private research center for aging research, and there are quite a number of speakers there, and it was basically a day of AI and aging, so it was very interesting. But I think also the benefit of AI, it's going to remove this 10 scientists, 11 opinion situation, because I think we're inherently limited as human beings to absorb information, whereas computers, well, very unlimited to what they can do. I mean, I have a key fob in my pocket here that stores 16 billion bytes of information, whereas 25 years ago, I think that was the entire storage capacity of the United States or something like that. I mean, so, but nonetheless, the rate of processing speed and the rate of storage increase is just, it's exponential. And so I think this situation where I think there's this Indian parable where there's an elephant and there's 10 people looking at different parts of the elephant, and one says, oh, it's a snake because it feels its tail, and the other one says, oh no, it's something else because it feels its toes, and so on and so forth. I think that will go away because with AI, first of all, it's unbiased and it has all the information. And as I mentioned before, just if you look at papers that have the word aging in it in PubMed, last year, 20,000 papers. I don't even know between the four of us we could read 20,000 papers in a year. That's a lot of papers, and be able to understand and regurgitate and assimilate all that information. And guess what? This year, it's going to be more, and then so on and so forth. It's going to be increasing exponentially. And so I think AI is going to play a huge role, and also the ability to visualize this information, because I think humans ultimately are going to be solving this problem, not the AI. We'll use AI as a tool. And so I think it's going to be pretty amazing what's going to happen in the next few years.
Yeah, I agree with all that, but I think in addition, I want to emphasize that precisely because aging is this systemic, very multifactorial phenomenon with the accumulation of so many different types of damage, we do always want to remember that it's likely that there will not be a single breakthrough that kind of dominates the future history of anti-aging research and development. That the repair of damage and the rejuvenation of the body is very much a divide and conquer strategy. It's something that requires the development of a wide range of different technologies, which eventually will all be applied simultaneously to all of us. And as such, the way that I look at it is, being at the coalface of anti-aging research, is that the breakthroughs that matter the most are the ones that get the least publicity because they are at the earliest stages. And the reason they're at the earliest stages, and also the reason they matter the most, is because they involve attacking the most recalcitrant, most difficult components of damage in aging, the ones that people for many, many years had basically given up on as being too hard. Some of the breakthroughs that we've made at Science Research Foundation that I'm most proud of are for that reason, that we've essentially been able to revive and kickstart areas of research that had lain pretty much dormant for at least 10 or 15 years just because people in more mainstream peer-reviewed academia had to work on more low-hanging fruit in order to get their next grant applications funded.
I think what helps us humans in kind of amassing all this data here in all the papers is that a lot of it's redundant, so that helps a lot. So regarding aging itself and I'll say longevity, I hear these two terms, aging and longevity, and I know that Leonard Hayflick, who's a famous researcher, Hayflick limit, a lot of you have probably heard of this. He basically discovered senescence in mammalian cells. He posits that aging is a consequence of physics, second law of thermodynamics, and longevity is a consequence of biology. Do you see there being a grand unified theory of longevity or aging? Is there something of that nature that we perhaps possess right now in the literature, or that you subscribe to, or that's something that you think is still not yet fully hashed out? And I know, Vadim, you probably don't believe that.
Definitely not hashed out. So, I mean, as we discussed many times at this conference already, there are more definitions of aging than the number of researchers in the field. Everybody thinks different, and they change their opinion. And if you ask a simple question, when does aging begin? Whether aging is a disease, just completely different answers to it. So I think it's important to build that foundation so that we could agree upon what this is and what we are trying to target. So even discussing that aging comes from damage accumulation, it's too diluted kind of definition, because damage comes from every process, and it's not just damage. It's other deleterious changes, imbalance in cellular components, too many cells in an organ, maybe a 1% more glucose in the blood. It's all deleterious changes as a function of age. As a function of age, everything changes in the cell. Most of the processes change, and they are deleterious. When we say that we will kind of understand all of them and remove them, I think it's just not feasible. So it's not feasible to stop aging in that, and from that sense. No matter what we say, how exciting, how we will conquer it in 30 years or in 100 years, we will live 200 years or 500 years, it's just not going to happen by saying it. We need to understand the aging process. I think this is the main thing.
So I think a previous speaker mentioned that aging is a multifaceted problem that occurs at multiple levels, and all those levels, their feedback systems and so on and so forth. So I think aging is not one problem, but several problems, and I think what's going to end up happening is that some interventions will take place early on that will extend life a little bit, 10, 20 years, and then again, more work will be done, and that'll extend lives maybe 30, 40, 50 years, and so on. So I don't think it's going to be a eureka moment where, oh, hey, I discovered how to cure aging. I think it's going to be an incremental process, and I think that process will take a while. And I think as far as what aging, at least my view of aging is at a more physiological level, not a cellular level, because I think that's where we're going to start first at the physiological level, then start burrowing down to the cellular pieces and genetic and so on. But just something very simple, and I think all of us can understand this. Estrogen. We all understand when women's estrogen levels decrease to a certain point, we understand what happens at that point, right? They go through menopause and so on. So that's a very, very simple aging type of process that takes place that's very understandable by the layperson, basically. Estrogen levels go up during puberty and so on in women, and then they plateau and they drop off, and then in their 50s they lose the ability to have children and so on and so forth. And so that's all basically, it's more than just one hormone, but basically estrogen is the major component in that process. So I think it'll be attacked at the hormonal level, because again, if you look at the hormone profiles, let's say of a 20-year-old versus a 70-year-old, you're going to see some radical differences. And if you just imagine this little thought game you play, I mean, imagine a 70-year-old going backwards in time. What is their hormone profile going to look like? In other words, what normally takes place is, let's say, growth hormone, okay? Growth hormone goes up, it peaks, and it goes down. Now, if you play the movie backwards, growth hormone levels are actually going back up again. Now, I know that's very simplistic, and the machinery is different now. So the 70-year-old has a 70-year-old body, and a 20-year-old has a 20-year-old body. So replaying or playing the movie backwards is not exactly the solution. But I think it would be common sense to imagine that a long-lived person would have hormone profiles very similar to a 20-year-old. And so that looks at the physiological level. But then, of course, there's a cellular level, which has to be addressed too. So once again, I think it's going to be a multi-stage process. It's not going to be a eureka moment. It's going to take multiple steps to slow this thing down to a crawl.
Yeah, I think, okay, so I want to really emphasize why I am more optimistic than most people who work on the biology of aging. I think a lot of the reason why I feel I'm right to be more optimistic than average is that I think about this in terms of what we need to understand and what we don't need to understand. It was only when I started getting into this field in the mid-90s that I really began to appreciate the profound difference of mindset that exists between, on the one hand, basic scientists, and on the other hand, technologists. Basic scientists are all about finding things out for the sake of finding things out. And my ex-wife was, a very prominent biologist all her life, and she was very much that sort of person. I would say to her, well, why aren't you interested in aging? And she would say, well, it's just, decay. What fundamental truths are you going to find out about the universe by studying decay? And I would say, well, yeah, sure, that's true, but it's bad for you. And she would say, well, yeah, but that's not my problem. And I would say, well, it kind of is. But it never really got through. So I felt, I've got to do it myself, really. The thing is that when your training and your mindset is all about understanding nature, testing hypotheses, improving knowledge, then you use information, you use evidence in a very different way than if you're a technologist and your training and your expertise is about manipulating nature. It's just a completely different thing, and I never understood how different it was until I started thinking about that. So now I believe we're in a situation where we can look at the phenomenon of aging, which is every bit as complicated as Vadim says it is, no question. But then in terms of doing something about it, the first step has to be to figure out how to minimize the fraction of aging that we actually need to understand in order to achieve some manipulation, and to maximize the amount that we can get away with not understanding. That's really what led me to the concept of comprehensive damage repair as a promising approach in the first place. It's also what led to my being viewed as crazy for a long time until it became apparent that I wasn't. I believe that this way of thinking about dealing with aging does justify the optimism that I have, even though there's still a long way to go to get people to really accept it. One thing also is that it's not just a single linear spectrum between pessimism and optimism. So here's something that I don't know if he will be angry at my revealing it, but I'll do so anyway. The guy who runs the Buck Institute, Eric Verdin, very, very prominent and very, very bright and good gerontologist, he is every bit as pessimistic as Vadim, or perhaps even more so, with regard to the near term, with regard to our...
I'm sorry. I'm actually optimistic about aging research.
Well, then he is more pessimistic.
Or maybe you can say realistic. Why is it pessimistic?
Well, I think the words realistic and optimistic are often misused. You say you're an optimist, people think you're an over-optimist. You say you're a realist, people think you're a pessimist. But yes, Eric is very pessimistic about the rate of progress that's likely to occur in the next 10 or 20 years. He thinks that we'll be very lucky if we can extend human healthy lifespan and therefore human total lifespan by more than 5 years in our lifetimes. But on the other hand, he believes that once we do get to maybe 20 years of extension, then he agrees with me that we will reach this thing that I've called longevity escape velocity, where we are pushing back the rest of aging incrementally, as Steve says, but faster than time is passing. And therefore, we effectively have completely defeated aging, even though we haven't really defeated it. This is something that hardly any gerontologist will be willing to say publicly because it scares the funding agencies. But the fact is, it's pretty obviously true when you think about it.
So switching to practical applications, I think we all agree here that you don't need to have a firm theoretical understanding before you can actually have interventions. That's basically been the story of medicine throughout its entire history. What would you say, to people out there who are, curious about up-and-coming therapies that are just on the horizon, that are perhaps trickling in right now into trials, perhaps even being, used by some people off-label? Can you give like a scope or a timeline of interventions that you see happening soon? And then, maybe you can speculate on what might happen later. But let's start with the soonest things that you would see, what you think, hitting the market or that people would experience, that you think.
Can you start from that side now?
All right. Of course, there are some fairly obvious examples that have already been mentioned today and will be mentioned this afternoon, things that are going to be in clinical trials very soon, or even already are in clinical trials. When I started the Medvedik Foundation, especially when I started Sense Research Foundation, the main criterion that we used to prioritize what research to do was that other people were not already doing it perfectly well with perfectly good funding. And the only area that led to our deprioritizing, really, was stem cell research. Loss of cells is one of these 7 categories that I've been talking about all these years. And we've done virtually no work on fixing that because all the really important stuff was being done by other people. But somehow it was not seen broadly, in the broader audience as emblematic of the comprehensive damage repair approach, and therefore it didn't work as a way of selling it as a realistic way to go forward. I think that's now completely changed, especially with what's happened with Senolytics, that have really taken the world by storm in terms of not only getting a lot of press, but also getting a lot of money. The fact that we've now got a company based on unabashed damage repair that is valued at 10 digits, that's a very big difference. And they're going to be in clinical trials, in the next year. After lunch, we're going to be hearing from Kelsey Moody. I guess he's going to talk about the fact that our approach for eliminating the damage that drives macular degeneration is also going to be in clinical trials pretty soon, courtesy of their own work at ICOR, which we pioneered at Sense Research Foundation. It took us many years to get to a point where it could be taken private, but we managed it. And, this will just be a continuing process of bringing things to far enough along to get working in animal models and then to clinical trials. But we're very close now in a lot of the areas of damage repair that are the most critical.
So I think as far as technologies are concerned, there's, I believe that the more or near-term solution will be generated pretty much by stabilizing the hormonal profile of our bodies. And there's a company called Dexcon that's doing something like that with diabetes. And they have ways of basically monitoring your glucose levels and so on all by a device that you attach to your body, and it's monitoring your glucose and updating your cell phone. And so I think the solution will be pretty much like that. You'll be monitoring your estrogen levels, your growth hormone levels, all the hormones that are basically declining as you grow old. And there'll be mathematical formulas to inject the right amount at the right time, because again, a lot of people, and I don't think we've heard this, I'm not sure we're going to be hearing this today, but again, circadian rhythms are very important as to when you inject the right hormone at the right time. It's very important because again, all these things are cyclic as well throughout the day. So I think those are the technologies that I believe are going to be important near term. But one other thing as far as technologies are concerned, as far as aging, and again, it's not been addressed, what if you're 75 years old right now? What if you're 80 years old right now? Clearly, none of us have a solution for you right now. So again, it's not talked about very much, but I think cryonics is a very important technology to mention, because again, it provides a technological lifeboat for those folks not fortunate enough to be young like the four of us up here. And I think that's something that I think we should talk about more, because I just don't want to basically throw away a whole generation of people because we just won't be able to figure out the problem soon enough for them to be recipients of it. So I think I would encourage people to look into that field and look into companies that are in that field, because I think it's going to be a pretty much a growth industry, at least until we figure out how to slow down this process.
I think we have to ask a question, what these recommendations or suggestions will be based on. So in humans, we cannot run an experiment and test the effect of any intervention or lifestyle or therapy on lifespan. So the only way to test an intervention is to use a biomarker. Once better biomarkers will be developed, then I think what will be used by general public is something which we already know. It's a combination of lifestyle changes and maybe some pharmacological interventions. I don't know whether it's going to be metformin or rapamycin or any combination or some other compounds like that. Because we will know that based on statistics, I don't know, the UK Biobank develops, there is many large collection of databases that now being accumulated. Once they run across through these biomarkers, we will know which changes in lifestyle and which interventions might be extending lifespan. So I think they immediately can be used.
I actually disagree. I just wanted to interrupt because I think that, yes, absolutely, biomarkers are extraordinarily important. They will be enormously helpful, but we can actually do clinical trials where lifespan is the endpoint if we are talking about rejuvenation therapies, damage repair therapies, because it only takes, let's say, 5 years if you're taking a population that's already on the Gompertz curve in a long way, like they're age 70, for example. It only takes 5 years maximum to really demonstrate rejuvenation if you've got it and it's working. So I believe that increasingly we will be able to use actual death as the marker.
It depends on what you mean by rejuvenation. What do you mean by rejuvenation?
Well, I mean...
How would you measure it?
What I'm saying is that biomarkers would be the best way, but even if we only had death, that would still be a good enough marker because we're talking about a period of life at which death happens quite often. 5 years is enough.
Then we cannot say rejuvenation. We cannot claim rejuvenation if it's just an extension of lifespan, right?
Well, it's very hard to uncouple the two things. Health and life, being sick is risky.
By definition is going from an older state to a younger state.
Yeah,
right?
but being sick is risky,
so
right?
Converting a subset of cells, perhaps in the organism, to a younger state, we have to measure it, that they go from an older state to a younger state. For that, we need some kind of a marker or an assay, like epigenetic clock, for example, right?
Well, I think one thing I just want to mention is that the word health span has not been mentioned. I think maybe that's where Aubrey's going with this, is that increasing health span, so life and fewer visits to the hospital. How about that? I think that's a pretty good way.
Activities of daily living, all that kind of thing. Yeah. But yeah, again, I do want to emphasize, I'm not in any way denying the value of biomarkers. I'm just saying that we do have other options.
Great, and I want to save a few minutes for the audience because I promised questions will be taken. I'm not a medical doctor, but I would recommend right now you could start taking resveratrol supplements in a carrier of red wine. I do that twice a day. Works, at least for your mood. I'm not sure about longevity. The experiment is still ongoing. I'll let you know at the end how it worked out. So right now I'm going to pass the microphone forward. I know there was a hand up right there somewhere, this gentleman here.
I have a comment and a question. One thing that we might be able to do to measure rejuvenation, we might not even need to use deaths. We might do something such as grip strength in the elderly or frailty in the elderly. Those are empirical categories, and that could take even less than 5 years. If we could demonstrate an intervention, maybe we could look at 2 years later or the duration of the intervention. So that's the first thing we might be able to use as rejuvenation, excuse me. And I actually had a question. It might be a little personal, so if you don't want to answer, I understand. But along the lines of taking resveratrol in a glass of wine, I was actually wondering if any of you seriously incorporate any of these anti-aging regimes into your own life. For example, specific diets, timing of diet, or even supplements such as metformin.
Actually, I can start with that first. People ask me all the time, so Steve, you're doing this aging work. What can I do? What can I do to extend my life? And I tell them 3 things. Eat well, exercise, and be happy. That's the only thing right now that you can do that's going to work.
Yeah, I say, give me large amounts of money. That's the only thing that's going to work.
Number 4, give Aubrey lots of money. Thank you.
Intravenously would work, yeah.
I have a question about the biomarkers that you mentioned. Which biomarkers are you talking about?
There are various biomarkers that are currently available. So I think the best one, as I mentioned in my talk, is DNA methylation clock. Because this way one can trace millions of different CPG sites and identify some sites which represent the aging process. There are some other biomarkers based on metabolites in the blood, for example, or some other metabolites, like somebody mentioned, this frailty index, like strength, grip strength. So they all can be considered as a biomarker. It's unclear what is currently is the best. So in the future, probably they will be integrated and combined, and even better biomarkers will be developed. This would allow us to trace the aging process, and very quickly. Yes, we can look, perhaps in a larger population, we could run a trial with many people and then perhaps follow them for 5 years. With biomarkers, just will be easier because we don't need for them to die, for example. Yeah. So so something which can measure the aging process. Because if you, for example, skin might age slower than other organs, or changes in the blood might not represent the aging process in an entire organism. The question is how to find something which represents the aging of the entire organism, not a particular system.
Yeah, the only real difficulty that I have with biomarkers is that you don't necessarily know whether they're still going to be biomarkers in the context of an intervention. They may track with the chronological age or the age until death pretty well across a population that's not being treated, but your treatment may disrupt the aging process in a way that doesn't disrupt the biomarkers, or vice versa. And of course, you'd hope that that mostly wouldn't occur, but it is a caveat that one always has to be aware of when one is identifying biomarkers. One has to have good biological reasons for believing that they will continue to correlate with biological age in the context of whatever interventions you may be introducing.
Address the controversial issues about telomere extension, whether that, it's a little confusing. Do you go forward with it, not go forward?
Okay, quick answer. Telomeres. Yeah. Okay. The question was, are telomeres good or bad, more or less? Is telomere shortening good or bad? Is telomere lengthening good or bad? And of course, the reason why this is a controversy is because there's no one answer. It's perfectly clear that telomeres get shorter when cells divide, and that we have an enzyme called telomerase which counteracts that by putting additional sequence on the ends of our chromosomes. There are cells that divide quite frequently in the body and therefore have a lot of telomere shortening that needs to be compensated. The cells that divide the most often express a bit of this enzyme telomerase so that they do compensate. Cells that don't divide at all, or that hardly ever divide, don't need to worry about this in a currently normal lifetime. Unfortunately, we also have the problem of cells that divide when we'd rather they didn't, namely cancer cells. So one can argue it both ways. One can say that we need to rescue those cell types that are suffering from telomere shortening in order to rejuvenate us. And I think the best evidence in favor of that way of thinking is with regard to the immune system, which certainly has a lot of cell division that may not be adequately compensated by telomerase. And the converse argument is we may need to use telomere shortening as a way of controlling cancer. Now, really, therefore, the answer to the question comes down not to what we should be doing with telomeres, but to what else we can do elsewhere in aging. For example, if we figured out a way to completely eliminate cancer that didn't have anything to do with telomeres, like immunotherapy, for example, supposing immunotherapy got really, really good, then bang, we no longer have a reason not to extend our telomeres, so the argument in favor of telomere lengthening becomes very strong. Conversely, if we find other ways to keep cells that would normally undergo replicative senescence from doing so, but without extending telomeres, then we might be able to use telomere shortening as a more powerful cancer therapy. It all depends on which of these technologies comes along first and turns out to be easiest.
Yeah, I think telomeres may be a factor later on. In other words, if we extend life to 150 years and so on, that could play a factor. But I can tell you that the reason why estrogen levels go down and why women go through menopause in their 50s has nothing to do with telomere shortening. And the reason why our dopamine levels go down in our brain and we don't have that get up and go like we used to have when we were 20, I don't think that has anything to do with telomere shortening. So I think telomeres may play a role later on, but I think near term, I don't think they play a factor in why we die at the age of 80 approximately right now. So.
I'd like to thank our panel right now for the discussion we had, and there'll be plenty more panels later this afternoon. Thank you very much.